Right. So our target today, we will try to cover the basic ideas of reflection chapter. I will not go that deep in everything. मैं कोई यहाँ पे भी रे डायग्राम ड्रॉ नहीं करने वाला हूँ, बट आपको ये सब बताऊंगा कि रे डायग्राम के लिए क्या चाहिए. And then we will go into practice problems. So a lot of case based. So I'll hand over a complete directory to you, and that directory will help you with all case based questions as well as other questions. And again, your time will start from today, and you can ask questions. Okay. So you have any question with reflection you don't understand, you are most welcome to stop the vehicle then and there and ask me. So in light, we typically have NCERT deals reflection and refraction in one chapter, so you can take it as one chapter, and after that there's one more chapter which is human eye and the, yeah.
So you're on mute.
I'm still on mute. I thought I had unmuted. When is the class timing, Vivan?
I forgot my laptop.
I told you one day, laptop is not that important. Important is to come to the class. Okay? Right. Am I audible now, Pihu? So what I was saying, what we'll do today, we will start with reflection. Okay? One class of theory today, which will be like a crash. If you don't understand anything, or you feel that sir has not covered this and I'm having a doubt on this, please feel free to ask. Reflection, refraction, human eye and the colorful world. After the class ends, I will give you a compilation. Basically, you'll get a Word file with a lot of links. Each link will take you to questions. So we'll solve some case-based questions, and the questions are like this, children. Reflection case-based, refraction case-based. Then there is one link which will have reflection, refraction combined. Right now you do the reflection one. Then there will be one or two PDF booklets which are all numericals with every answer given, and it will be combo of reflection, refraction. जहां जहां mirror देखा करते रहो अभी, ठीक है? चले. So in reflection, point number 1, the first thing for case-based questions, which is more important for us, we have to know the topic. Tell me, are you clear with reflection as a phenomenon? When light rays fall on a surface and they are falling through a medium and they are sent back to the same medium, that phenomenon is known as reflection, right? Ray is actually an imaginary concept. There is nothing called ray. Ray, we do it for geometrical drawing purpose, and a collection of rays is known as a beam. These are grade 8 topics. Is this fine? Okay. Now, after this, we would also like to know a little bit about grade 8 topics. We will start. The best reflecting surface is that known as silver, and all reflections take place from what is known as the polished or the smooth surface. Usually, if you are dealing with a plane mirror, then the edge surface is the rough surface, the polished or the smooth surface is this one, and this is the surface through which reflection is taking place. यहाँ पे थोड़ा सा हम बात करेंगे. Once again, we'll talk a little bit about plane mirror. It's not plane, it's plane. This is the word, plane mirror. So plane mirror means straight mirror. A plane mirror is a piece of glass on which on the back side you have a coating, generally red oxide. Now before the coating, what you'll have a reflective film, usually silver film. As costly as the film, as costly as the glass. It will be very, very thin film and then a red oxide layer. So plane mirror, what is important for us to understand are the image properties. Usually we get 5 image properties in plane mirror from grade 8. Remember them. Number 1, object distance will always be equal to image distance. These are plane mirror, okay? Object distance will be equal to image distance. Video is getting recorded, so don't worry. Object height will be equal to image height. The image will always be erect. This is like you yourself seeing in the mirror, right? The object will always be erect. The object will be virtual, right? That's the 4th one, and the object will be laterally inverted. This brings us a new concept out here called virtual. So have your concept clear about virtual and real. Images which are formed by intersection of rays are known as real rays. Images which are formed by intersection of virtual rays are called virtual image. Now question comes then, sir, what is a virtual ray? A virtual ray is a ray which is extrapolated by you. Actually, you found that the rays are divergent, so you extrapolated and brought them back dotted. And you get an image which you think that the image might have been here. That is known as a virtual image. Cannot be taken on screen. A virtual image cannot be taken on screen. only real images can be taken on screen. So one of the way to distinguish between a plane mirror and a concave mirror is a concave mirror will form an image which will fall on a screen like a window or a curtain, but a plane mirror will never give an image on a screen, because in plane mirror the image is formed behind the mirror. So in plane mirror the image is always formed behind the mirror, right? Whereas in concave mirror the image will always be formed in front, barring one case which we will see slowly. So tell me, phenomenon of reflection clear, understood? Silver is the best reflecting surface. कभी 1 mark question पूछ लिया तो what is a plane mirror? Plane mirror में हम बात करते हैं 5 things: image distance equal to object distance, image is erect, image height equal to object height, then the image is virtual and the image is laterally flipped. So lateral inversion भी यहाँ पे आपको थोड़ा सा जानना चाहिए. This is a grade 8 topic, inversion. That's all. We are done with the basic that was required. Now we start our discussion on our next topic, which is known as spherical mirror. Spherical mirrors. So spherical mirrors are a part of a sphere, So you have to have your imagination. All I can be able to draw here is a circle, but imagine that this is a sphere, like a globe, right? शीशे का globe है, mirror का globe है, and from this globe chop out a portion. As I said, one of the best way to understand is like the Jewish cap, or the cap the Jew men who wear. वैसा cap जैसा, saucer जैसा है. So it is not straight, it's something like this. What you see in your parking right near the old Ratnadeep, you will see a spherical mirror, that's a convex. So in this spherical mirror, what we do, we actually, I can't cut off from this software. So let's take the center line out here, and let's try to see on both sides, okay? Now, you get to form 2 types of spherical mirror depending upon on which side you are etching in. If I etch on this side and make it rough, okay, so it forms what is known as a convex mirror. And if I etch on this side, it is a concave mirror. And one of the ways to understand it, as I said, imagine a person sitting here. He feels he is sitting under a cave. So this is a concave mirror. This side will be my concave, and this side would be my convex. Convex का पेट हमेशा मोटा होता है, इसका पेट मोटा है, bulging outwards is known as the convex mirror. Okay, as we study reflection, our 99% study will always be on concave mirror. Every question that you get will be always on concave mirror. And when you study lenses, every study will be on convex lenses. Convex mirror, maybe bad luck is very bad, you may get a question, but why they don't give a question? Because there's no chance of fooling you in that question. Whereas here there can be enormous different combinations of images, whereas in convex में एक ही होता है. The best way to understand convex, अभी यहाँ पे देखने से, this is your rear view mirror of car. Rear view mirror, you do not see 2-3 different type of images, right? So in convex you don't have a versatile platter, whereas here you have a platter. So you will be judged more on this, and in lens you will be judged more on convex lens. Is that clear? Right. Time now for us to understand few of the terminologies of this particular thing. Is it going okay, or थोड़ा fast तो नहीं जा रहा है? Right, good. So let's see. Let me check whether they allow deletion here or not. I don't know. So 1 minute. And this software doesn't allow sometimes. Let's see. It doesn't allow selection erase. It erases completely. So we have no other option but to have a free drawing. Okay, so I start with concave mirror. Okay. So let me draw the sphere from which my mirror has come out. This is my sphere, and I'm trying to take a portion of it. So the sphere definitely will have a center. So let's say this is the center of the sphere, C. This is the center of the sphere, not a circle, center of the sphere. And I'm trying to take this portion out. So this is the portion that I've taken out, and I have etched on the outer side. Now, since you have taken a patch out from the glass sphere or the mirror sphere, then that patch will have a center. Imagine, children, this is not a broken bangle. This is like a saucer, a cup saucer, as I told you, like that Jewish cap. Okay, so here we will have something which is known as the center of this particular mirror, and this center of mirror is usually denoted always by P, known as the pole of the mirror. This is the pole of the mirror. And the center of the sphere, right? The center of the sphere on whose curvature this mirror lies, this center is known as my center of curvature. So somewhere here, see, this will be known as the center of curvature. What is the center of curvature? The center of curvature is the center of the sphere from which, of whose portion the concave mirror belongs to. The concave mirror has been chopped out. Is it clear? Has been chopped out from the sphere, right? Fine. Then what do? We have our few imaginary axes. So we take our first imaginary axis and we say our first imaginary axis is such that it is the line joining the center of the mirror to the pole. Okay, the line joining the center of the mirror to the pole, like this. And this will be known as my principal axis. Principal, P-A-L, not P-L-E, principal axis is known as my principal axis, the line joining the center. Clear? Okay. Then, if this is understood, the next one is to understand that what is the measurement of the radius of the sphere from which you have cut out this mirror. So this will be known as my radius of curvature. And this will be R. These questions, they might put you in a case-based question. What is R? You define it. So radius of curvature gone. This is gone. Right. Okay. Then comes another point. Just keep it for your information. Let's say it's only this much portion of the mirror. Let's say this is a portion of the mirror which is actually exposed to the incoming light. Samajh rahe ho na? Not everything is exposed to the incoming light. Let's say that what I'm trying to say is that this portion, the light is not hitting you. Okay, this portion, the light is not hitting you. The light is only hitting this much portion. Then this particular portion will be known as my aperture. A-P-E-R-T-U-R-E. Aperture is the opening of the mirror which is exposed to the light. मतलब सारा reflection का खेल aperture से ही होगा. Perfect? No issues? Okay. Sorry. So that's there. Okay. Fine. Concave, convex we have done. Principal axis done. Aperture done. Right. चलो आगे बढ़ते हैं. So far okay. Now let's go to the more basics of it. So let's take my concave mirror. Okay. And let me construct my principal axis out here. My principal axis. Okay. Now, time now for us to understand what we mean by the word called the principal focus. Principal focus. And we are first trying to study the principal focus of a concave mirror. The principal focus of a concave mirror. So this is my concave mirror. This is the principal axis. This is my pole, and this is my center of curvature. So if a parallel beam of rays, let's take a parallel beam of rays, which is parallel to the principal axis, right? This parallel beam of rays, when it hits a, this later on will get more clear, when it hits a concave mirror, it will pass through one common point. Okay, the entire beam will pass through one common point, and this particular point is known as my principal focus. Okay, so how do we say? The principal focus of a concave mirror is a point on the principal axis. अभी time नहीं हो सब definition लिखने का, record हो रहा है, सुनते जाइए. Listen more so that you absorb it. The principal focus of a concave mirror is a point on the principal axis at which a parallel beam of rays, after getting reflected from the concave surface, converge upon. So what do we see? These rays initially were parallel rays, and then these rays have become what? These reflected rays have converged. Therefore, this is also known as a converging mirror. They have converged, and the point at which they converge, this point will be known as my principal focus. Principal focus. So if you look at this principal focus, जरा देखो इसमें कैसे rays converge हो रहे हैं? All real rays. I did not make any rays as dotted. Therefore, the principal focus of a concave mirror is always a real focus. ये आपको पूछ सकता है. Why is it a real focus? Because this focus is obtained by the actual intersection of rays, right? कभी-कभी जरूरत पड़ता है, like if you know it, nothing bad. So let's know that also. So we'll have a virtual focus when we see that. So out here, sorry. So at this focus, you will actually have, now look, we are trying to have everything it is in this way. See, try to understand the drawing. Let's say that what you call the window out there is my concave mirror. That's the best way to understand. It's like an open umbrella facing me, or a dish TV antenna, and the principal axis is just going through it. The rays have gone there, and the rays have come and intersected on the principal axis. Now, if I stand here and I face that what you call concave mirror, and I try to put one plywood right like this perpendicular, so I have created a plane which is through the focus and perpendicular to the principal axis. I have created a plane which is through the focus but perpendicular to the principal axis. Such a plane of mine will be known as the focal plane. अब इसकी, you know, your book doesn't discuss, but what the best way we'll understand, you will always say that when object is placed at infinity, image is formed at focus, right? That is when the rays are coming parallel to principal axis. The rays could have come parallel to themselves but not parallel to principal axis. Then also the rays will come in this manner. Are you understanding what I'm trying to say? How do you understand that only rays are going to come this way? No, rays could have come this way also, or the rays could have come this way also, but I'm saying a parallel beam is coming, not parallel to the principal axis. Then also they will intersect, not at the focus, but exactly on a line which is the axis of the focal plane. तो वो कहाँ intersect करेंगे पता है? Then they will be intersecting either here, 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 here. This is called the focal plane. So if you have a parallel beam of rays which are coming and hitting a concave mirror, their intersection will always happen on the focal plane. If the beam was parallel to the principal axis, the intersection happens at the focus. और focus है क्या? Focus is the intersection of, ये सब तो काल्पनिक है ना, principal axis and the axis of the focal plane. एकदम पैरेलल आते हैं तो फोकस में, एकदम नहीं हो तो उसी फोकल प्लेन में रहोगे. क्लियर? So parallelly what we will do, will not waste time. So we will also understand the principal focus of a, convex mirror. So convex mirror मतलब जिसका पेट मोटा है. Right? This is my convex mirror. Okay, and suppose I am extending the same principal axis. So let's extend the same principal axis. This is my principal axis. Now let me give names to this also. So I'll write these names with what you call, say, pink color, because it's a different mirror. So P, this is the pole of this particular mirror. This is the center of curvature of this mirror. Okay, let's see now what is the scenario which is going to happen out here. So we will have a parallel. So beam of rays always by convention are taken to come from left to right. Okay, so let's see. A parallel beam of ray has come here. A parallel beam of ray has come here, here, here. Now, in this case, what happens? They used to converge. In this case, they will diverge. अब यहाँ पे मैं थोड़ा सा 2 नंबर ही करूंगा, लेकिन आप अपना मिला लेना डायग्राम जैसे मिलाना है. So they will diverge. So I'm first trying to make the divergent like this. Oh, sorry. They'll diverge this, like this. And now start taking my arrows. Have you understood? A parallel beam of rays have gone and hit, and they have diverged out from the surface. Will they ever intersect? No. But we try to extrapolate and bring them back and try to think from where did they originate? कहीं ना कहीं किसी common point से तो निकला होगा, और वो common point को हम क्या बोलेंगे? The principal focus. This will be known as the principal focus of a. This is the principal focus of a convex mirror. Principal focus. So if somebody says define the principal focus of a convex mirror is the point on the principal axis from where rays after beam of parallel rays after getting reflected from the convex surface appear to diverge from. जहां से एहसास होता है कि वो लोग निकले थे. ठीक है? Now look at these rays. This point is formed by the intersection of all dotted. So this is a virtual focus. ये क्या हो जाएगा? ये हो जाएगा virtual focus, and this focus is always in front. If you look at this, this is behind the mirror. ये mirror के पीछे है, behind the mirror. And if you look at this particular focus, then this focus is in front of the mirror. In front of mirror. अपने आप आपका concept clear होता जाएगा. And the distance FP, whichever mirror you are saying, this is known as your focal length. The distance from the focus to the pole is known as focal length, always denoted by small f, and the relation is such that small f is always half of the radius of curvature. ये आपका formula. Whether which type of, doesn't matter whether you are a concave or you are a convex, the focal length is always half the radius of curvature. So this is your formula number 1. Are we there? Okay? Understood? Right. Till here, any questions? You can ask a question. If your question, I think, is from a section which is ahead of it, I will myself stop it, but do not have any inhibitions to hold yourself. You can always ask. Clear? Yes, sir.
There is a part which does not get the light.
No, not get the light की बात नहीं कर रहा हूँ. अभी देखो, अब एक बात सुनो. ये मेरा खिड़की है पूरा. Whole this thing is glass. The sun has just come out, and the sun is coming through so many towers in Pebble City. Suppose the sun's rays have hit only till this much. Possible, no? Only this much portion is illuminated. This much right now is the aperture. Aperture is the portion which is exposed to the incoming light. But if you look at my balcony on that side, now that completely is exposed. So aperture is the whole glass. कैमरा में भी हम aperture कम करना मतलब exposure कम कर रहे हैं. ठीक है? Right? No issues? Can we go ahead? चलिए आगे बढ़ते हैं. And now we come to what is known as rules for image formation. ये आपको याद रहेगा, आप अपने आप सब बना सकते हो. Rules for image formation, and we will see both for convex as well as concave together, क्योंकि हमारे पास इतना तो टाइम नहीं है. क्या rules? 4 rules होते हैं, हमेशा इसको याद रखिए. The rules are 4 rules. Okay, so 4 rules के लिए 4 positions बना लेते हैं. 1, 2, 3, and then let me make the 4th one out here. Then 1 rule, 2 rule, 3 rule, 3rd rule, and say 4th rule. ठीक है? So चारों rule के लिए, first of all, let me make the principal axis. So this is my principal axis 1. This is my principal axis 2. Principal axis 3. This is my principal axis 4. ऐसे आप करोगे आप खुद ही सीख जाओगे 1 2 3 and 4. By the way, how many of you did some mathematics yesterday? If you are not doing, you are piling it up slowly. Okay, I'll be always talking as a devil's advocate now. Okay, let's look at our mirror. These are concave mirrors. So our mirrors are all like this, 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 this. Our mirrors are convex. This, 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 this. Let's etch them. So one. Right, let's go to our rules now. So rule number 1, a ray of, okay, I didn't do the marking is pending, so let's do the marking also. Pole, 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 F, C, F, C, F, C, F, C. So this is my C, F, P, P, F, C, P, F, C, and P, and F, and C. Fine. Right, chalo. Let's get into our rules. So the first rule, a ray of light which is parallel to the principal axis passes through the focus after reflection. A ray of light which is parallel to the principal axis appears to diverge out from the principal axis, from the focus. Okay, so it will appear to diverge out from the focus, which means like this. Is the first rule clear? Okay. The second rule is just the opposite of the first rule. The second rule will tell me a ray which passes through the focus after reflection becomes parallel to the principal axis. A ray which is directed to the focus becomes parallel to the principal axis after reflection. Okay, directed to the focus. So you should make the directed part also. So this is my directed part. Clear? Understood? Third one, a ray which is directed through the center of curvature does not undergo any reflection and actually comes back along the same path. Comes back along the same path. So how do you do it here? A ray which is directed at the center of curvature. You could have done it from the bottom portion also, doesn't mind at all. You could have done it from the bottom portion also, which is directed at the center of curvature. It comes back on the same path. So I should show the direction also. It's like this. Dandavai. Right? The fourth one is very easy. The angle of incidence at the pole is always equal to the angle of reflection. Now, why do we say like that? At the pole, it is like a tangent. Like if it is a tangent, it's like a plane mirror. So the law of reflection, the laws of reflection are valid for, you'll say, sir, is law of reflection not valid for spherical mirror? It is valid. At every point, the law of reflection is valid. Just draw the tangent and the normal should be perpendicular to the tangent. Okay. So what do we say here? That the angle of incidence at the pole is always equal to the angle of reflection, which means that if this is theta, this angle is also theta. And the same thing happens here also. So pretty much the same drawing. This theta, theta. कितना easy है देखो तो. Theta. ठीक है? These are rules for image formation. Have them absolutely handy. Once you know this, everything is in control. Right? Okay. Once this part is done, once this part is done, right? So we can make this small and keep it. just if you need to refer this part, and this is also done. Take this also. Okay, this to work. Yep. Now instead of rules for image formation, now we will see image formation cases. Okay, let's see the image formation cases. This side is concave and this side is convex. This part is very important for theory questions. Convex, concave. Okay, the first one is most important. And what we are all talking about object placement. We are all talking about object placement. I won't draw the ray diagrams now. I will be talking about the outcomes, and I'll also say some similar scenarios which are happening. क्या बात है, कुछ डिस्टर्ब हो रहा है? अरे कुछ पूछा है ना, डिस्टर्ब लग रहे हो? ठीक है? Okay. So I'll talk in terms of object placement. Number one, when the object is placed between focus and pole, इसको तो एकदम खा लो. This is very, very important for you. Focus and pole. Why this is very important for you? It is the one and only case when concave mirror will form A, virtual, B, erect, and the C I am not writing with the same color because magnified you will get in many cases. Magnified you will get in many cases, but here you will get virtual and you will get erect. Yeah, virtual मतलब ही behind the mirror हो गया. Virtual मतलब behind mirror. Good. Behind the mirror. अच्छा. अब इसको कैसे ये लोग आपके साथ गेम खेलेगा? Something like, imagine. Now you know the ray diagram. I'm not bothered about that. See, sometimes concave means what? You take a brand new spoon, and the side on which you put your food and you put it in your mouth, that side is the concave side. So if the object is taken too close, you don't know where is the focus, and you don't know, you know the pole, you don't know where is the focus. There will be some point till where you will see enlarged image of the pen that you have kept. As you pull your pen back, you're going to hit the focus. Sometime you'll hit the focus. The moment you hit the focus, after that the image will turn. और छोटा बड़ा वो अलग बात है. Immediately flip करना शुरू करेगा. Focus में ही flip कर जाएगा. But till the focus, it will be bigger. So as I say, इस case में, in this case, always remember, आद्या तुम तो भूल ही नहीं सकते हो. Dentist, lipstick, and spec shop. Okay. Then hotel के bathroom mirrors. हमारे घर में भी तो है. Why only hotel? Okay, तो आप कह सकते हो. Have you seen the bathroom mirrors of hotel? They have got two sides. One side, if you turn the mirror, you see completely straight till your body portion. One side, if you turn it, you will only see. So the mirror is actually plain mirror and concave mirror. So that when you're shaving and all, you can have a close look. The circular mirror which is there in your hotel rooms. Okay. So compact mirrors, beauty compact mirrors. That's why I say dentist, lipstick, spec shop, all these are coming. Dentist mirror is also dentist mirror, the mirror with which is on the ladle and it is put in your teeth. Dentist को उल्टा नहीं दिखना चाहिए, सीधा बड़ा दिखना चाहिए. So, and the mirror will be always near the tooth canal. So object is always supposed to be near the pole. ठीक है? So इसके ऊपर application questions 100% आते हैं, 100%. And if you are doing a problem on concave mirror, and say your bad luck is bad and you're getting an image which is erect. When we go for image convention, you're getting an erect image and you are getting a magnified image. If you have slight bit of fear, always check the object distance. The object distance has to be smaller than the focal length in that case, because the object is between focus and pole. Have you understood this? Okay, then only this thing will happen. Okay, number two we say at focus. Okay, if you keep it at focus, then the image will be formed at infinity. The image will be formed at infinity, and this image will be very, very large, means highly enlarged. It will be inverted, and it will always be real. आपके बाद सब real आएगा. After this, everything is real, everything is inverted. That's why I wrote these two in green color. Erect और नहीं दिखेगा, virtual नहीं दिखेगा. Erect में diminished होता ही नहीं है. Erect में diminished सिर्फ यहाँ होता है. Look at Jaideep Das, that bulky fat fellow. When we see him in our car mirror, we see him small, but we see him erect. You don't see me with my legs up. Erect में small सिर्फ इधर दिखेगा. Erect में small यहाँ नहीं दिख सकता है. नहीं, नहीं, नहीं. Right? Okay. So इसका application क्या है? The torch bulbs. Torch bulbs versus the reflector. Or, so how should we do it? We take a concave reflector or the ambassador headlamps of old days. The bulb is kept in such a manner that the bulb is made to glow at the focus. So any ray which are going from the focus becomes parallel to the principal axis, or those British period cars which you see, old days Rolls Royce and all. That is the funda. Torchlight and also the doctor's head mirror. अब देखो, डॉक्टर लेके दो टाइप ऑफ मिरर आता है. एक डेंटिस्ट मिरर है, एक डॉक्टर्स हेड मिरर. डोंट गेट कंफ्यूज. यू हैव सीन डॉक्टर्स हेड मिरर, द वन व्हिच द डॉक्टर wears like a DVD on his head. He will have a headband and the mirror will be like a DVD. Typically it is with the ENTs. If you have a ear infection, the doctor will switch on the light and will focus the DVD near your ear, so the parallel beam goes and travels inside your ear. Nowadays the doctor will use his or her iPhone only to illuminate your ear canal. That's a different part. And then there, so doctor's mirror is this case, dentist is the other case, है ना? डॉक्टर देखते ही मत लिख देना, हाँ सर virtual image enlarged object is placed between pole. Golden and black does not always mean the tail of a tiger. It can be a dupatta also, right? Very good. So have you understood this too? Can I rub them, bacha? Yes or no? Yes, we are going fast. We have to go fast. There's no other option. So these two are gone. Gone. Okay, these two are gone. अब इसे यहाँ पे छोड़ दो. बाद में revision हो जाएगा. Okay, the third one. The third one is opposite of the second one. The third one is opposite of now. Object is at infinity. Infinity. Then the image will always be formed at focus, and it will be very inverted. Sorry, it will be inverted, and it will be very, very, very small, which is also known as highly diminished. It will be highly diminished, very small, highly diminished. One of the application of those dish antennas. Our dish antennas are always like this. So all the rays from the sun are coming parallel. And if you want to view Tata Sky properly, then the LNB of the dish antenna is always kept at the focus, so that these rays come and intersect at the focus. And your LNB, which is known as the low noise base of your antenna, should be here. So if you have enmity with your neighbor, जाके इसको जरा हिला दो, इसका TV गया. Your Tata Sky is not returning signals. Please call the service center or dial 1-800. Also, ma'am, I just learned how to do. Is this clear? Infinity at focus. Chalo, next, number 4. Number 4 is between focus and center of curvature. So the the image will be always formed beyond center of curvature. This is like that pop singer Beyonce है ना, singer, वो से Beyonce जैसा है. Between F and C, Beyonce. तो Beyonce होने से कैसा हो जाएगा? This will be again inverted but enlarged. Inverted but enlarged and obviously real. इसका opposite कर लो. Number 5. Object is Beyonce. Then the image is between C and F. Now this will be what? Inverted but smaller and obviously real. Inverted but smaller but real. And if you are at C, then you are inverted और क्या रहता है? Same size. तो क्या देखने में मिला? देखो, everywhere you are inverted. Everywhere you are real, except dentist lipstick. Then फोकस में रहेगा इंफिनिटी एनलार्ज्ड, इंफिनिटी में रहेगा फोकस एब्सोल्युटली स्मॉल, राइट? ओके, infinity focus, this concept is also used by telescopes nowadays. Nowadays telescopes do not have both lenses. The first one is always a mirror, even the good telescopes that we buy. So when you focus your telescope towards say Jupiter, all the rays from Jupiter are coming and forming one image at the focus, highly diminished. But this image is also inverted. Jupiter is round रे बाबा, वो invert किया और straight किया, Jupiter गोल है. रसगुल्ला देने से आप बोलते कि सर वाई आर गिविंग एन इन्वर्टेड रसगुल्ला, रसगुल्ला इज रसगुल्ला, जुपिटर गोल गोल. एंड देन यू यूज अ लेंस, समथिंग लाइक अ concave lens or a convex lens, and you magnify this. Convex lens use कर लेंगे and we'll magnify the Jupiter and we'll see it bigger. And then we'll give far more AI configuration, we'll link it with our DSLR to pack on more image and this is ये principle है, ठीक है? So these are done, understood? In this mirror, convex, it is like if you say in that West Indian language, no matter wherever you place your object, your image will always be smaller than object. It will be erect and it will be real. And driving cars, I'm more interested to see whether there. Oh, sorry, it's virtual. Sorry, it's virtual. While driving a car, I am more interested to see whether the full picture of the elephant behind me. वो elephant का मुंह नहीं देखना है मेरे को. Yeah. So these convex mirrors actually give you always a very wide angle view. See, if you have a plane mirror, let's say if I have a plane mirror, then this is my view and this is another view. Okay, this is going this side, this is coming this side. Another ray comes from this side and this ray comes from here. So your view is only this much. You don't have a wide angle view. Or यहाँ पे, this is your eye. Let's say this is your eye. You have view only this much. But if you have a convex, then देखो तुम्हारा view कितना ज़्यादा है. This and then here. So this is one ray. This is one ray. This is getting reflected here. This is getting reflected here. Okay, sorry. 1 minute, huh? ज़्यादा draw कर दिया. Okay. Fine. So this is coming here. So this much is your viewing angle. These mirrors will be used where? Safety mirrors in parkings, security mirrors in shops, so that you don't pilfer anything. Shoplifting होता है ना? Nowadays people use CC cams, but this also is used. More or less on blind spots, this is used a lot. Right. Even in car driving, we always say in driving we say something called blind spot. No, not blind car. You know, in blind car we say blind spot. When you drive a car, do you know what is blind spot? If you go to US and all, you will always see there's something written on the back of the truck. In US, truck drivers are paid a lot. Truck means a big truck, जो एकदम Terminator 2 जैसा चलता है. उसमें लिखा रहता है, if you don't see my face on my mirror, understand what I'm saying? The truck has got it written. If you don't see my face on my mirror, I don't see you. That means when you are tailgating the truck, you should be able to see the truck driver's face on his big mirror. जो Volvo buses में mirror होता है ना. If you are not seeing that, then you are driving your car where? On the blind spot. Blind spot is very dangerous, which is Hyderabadis are famous for driving. You should always drive. The fuel tank door, have you seen? Driving near that place a two-wheeler, then the person who is driving the car, you don't come in any of the four mirrors. That's called you have come into my blind spot. Now I start taking a turn. I don't know, you all were very kids at a time. It happened in Glendale School. 3:30, the school had ended and a turn was taken. That is long back. This is around 2012-13. Turn was taken. There was a scooter who wanted to take a turn on blind spot. Literally kids saw like a football the head roll off. So blind spot is very dangerous. ठीक है, हो गया ये सब. तो convex mirror, अच्छा याद करते हैं. What are the uses of concave mirror? We have discussed the use of concave mirror a lot. Concave mirror technology can be used for dish antennas. Concave mirrors can be used as dentist mirror, doctor mirror, reflectors. Okay, even used for telescope. Convex mirrors find their uses where? Convex mirror finds their uses in rear view mirrors, and then they also find their use in safety mirrors as well as security mirrors. Clear है? चले आगे. अब आते हैं sign convention, the one which worries you more. So next is sign convention. Sign convention, and we will see for both the mirrors. Sign convention. The first one we are seeing for concave. So for sign convention, always try to first draw the Cartesian coordinate system. So let's draw the Cartesian coordinate. तुमको भी ना सार्थक बीमारी लग गया है आजकल, स्थिर नहीं हो, कुछ ना कुछ छटपट 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 चलता है, ठीक है? Okay. Cartesian coordinate system, we all know this side is always positive, this side is negative, this side is negative when you come measure this side, and this side is positive. Okay, some of the conventions that we have taken are that the mirror will be such that the mirror is always placed at the with the pole at the with the pole at the origin. Okay, with the pole has been the mirror, the mirror's pole is placed at the origin. This is my mirror. I am trying to do everything for a concave mirror, right? So this will be my P. Obviously I have a F out here and I have a C out here. Now what is the focal length? The focal length is equal to FP. All distances are measured from the origin. All distances are measured from the origin. So origin is my reference. So I will measure all distances from the origin, which means that if I try to measure what is known as the focal length, I will be measuring the focal length from the origin, and that's why for a concave mirror the focal length is taken as negative, because you're coming on left hand side. Clear? Object by concept will always be taken, an object is always taken on the left hand side of the mirror, that is the left hand side of the mirror, irrespective whether you are concave or convex. So let me say my object is here out here, and objects are always erect. Objects are always erect. That means the height of the object will always be HI, and HI by default, sorry, HO by default is always my positive, right? But when I talk about the object distance, okay, when I talk about the object distance, then obviously I'm measuring it from the origin, and the object distance is measured as what? U, and U will be negative for a concave mirror. Now don't confuse on this. You have three parameters to play with: V, U and F. So याद रखना, the brand VIP जैसे हम बोलते हैं ना, तो I stands for image. So V is always attributed to image. That means U is attributed to the object distance. Clear? Except that dentist and lipstick case. In dentist and lipstick case, how will we see our image formation? Our image formation will be behind the mirror. Okay, our image formation will be behind the mirror. It will be an enlarged image, and it will also be an enlarged image, and it will also be an erect image, right? So in this case, in this particular case, if I am measuring my image distance, I would measure it from this side, and for this particular case, my image distance V will come as positive, and this is for dentist and lipstick. ऐसे याद रखने का, ठीक है? इसमें पॉजिटिव, बाकी सब केसेस में इमेज इस साइड होगा. अच्छा, here HI will also be positive in this case. Understood? Rest all the cases we will find our image, whether it is big or small, we will always find that our image is on the opposite side. ऐसा साइड में होगा image. Arbitrary draw कर रहा हूँ अभी. This is just an arbitrary drawing. So in rest all the cases we will say that the HO is going to be negative. Have you understood? And the image distance as we measure it from here to here, the image distance for all other cases, that's V, V will be negative. Now please understand, when you talk about HI or you talk about HO, you usually have two parameters associated with them. You have two parameters associated with them. Clear ho jao. The first one will be sine. It has nothing to do with the algebraical value. This is the sine. And the second one is a magnitude. Okay, mag. The sine, if it is plus, means it is erect, सीधा है. And if the sign is negative, it means inverted. बात समझ में आया? Don't use this as -3 and 4, sir. +4, -3 small, +4 is very big. Nonsense. You will get 0. Big or small, we will always qualify with the magnitude. Say image distance, image height is 5, object height is 4. Means in this case, the image is enlarged. सर उल्टा है कि सीधा है, वो ये वाला चीज बताएगा. अगर ये प्लस है तो सर सीधा है, और अगर ये माइनस है तो ये इन्वर्टेड है. नाउ टेल मी अ केस. ओके, टेल मी अ केस. इन कॉन्केव मिरर, can this ever happen that the image height is more than the object height but negative? Yes. When object is placed between F and C, तो beyond C वाला केस में होगा. Image height equal to object height but negative at C. Image height smaller than object height but positive. Na. Image height smaller than object height but positive. Na. Positive means erect. Erect में छोटा उटा तो हो ही नहीं सकता है. Erect में एक ही केस है उस साइड में. Clear हो रहा है? So when you answer, you yourself will get to know whether you are answering it in a stupid manner or you are answering it correctly. Just think once, twice. Clear? Okay. Now we come to the formulas. One of the formulas we have for magnification, whenever you are using magnification for a mirror, then magnification is always negative V upon U. This is for mirror. If you use magnification for a lens, then it just becomes V upon U. यही फर्क है. मिरर में नेगेटिव आता है, लेंस में नहीं आता है. हाँ, that will also come. And HI by HO will be common for both. Magnification means how much bigger has the image become. So it is always an image over a height. When we are doing this, we will use our signs also. Magnification -3, image बड़ा हुआ है पर उल्टा हुआ है. Magnification -12, image छोटा हुआ है पर उल्टा हुआ है. मैग्निफिकेशन +12, सर फालतू बातें मत करो, कॉन्केव में हो ही नहीं सकता. मैग्निफिकेशन -1 हो सकता है एट सी. मैग्निफिकेशन +2 हो सकता है डेंटिस्ट. क्लियर?
Even if it's like the sixth case, which is this image is between F and P, then also magnification.
Image is between F and P means dentist case. So magnification will be more than 1. Magnitude will be more than 1 and it will be erect. So it will be plus. You got it? It will be plus. Whereas in car driving experience, our magnification is always plus less than 1. Do we see? हाँ, plus, because हाथी दिखता है हमें. हाथी ही दिखता है पर छोटा दिखता है. कार मिरर में हाथी पूरा हाथी दिखता है ना, या आप सिर्फ हाथी तुम्हारी आंखें देखनी है मुझे, ऐसा थोड़ी है. Right? So in convex mirror, what do we see? In convex mirror, magnification is always plus, but the value is less than 1. Greater than 1 convex mirror नहीं हो सकता है, हो ही नहीं सकता है. Right? And wherever you put, generally in convex mirror, we see two cases, between pole and focus and at infinity. In both the cases, the image will be at infinity रखने से focus पे होगा, otherwise it will be between pole and focus होगा, ताकि पास हो. Right? Is this clear? This brings us to the mirror formula. Now always remember, in mirror there is I. In the word mirror there is I. And in the word addition there is I. That means mirror में हमेशा addition होगा. In the word lens there is E. In the word negative there is E. This is my way of remembering. तुमको अगर और कुछ अच्छा आता है तो रख लो, सर वी डोंट लाइक यू, यू टेक योर. तो उसमें होगा 1/f is equal to 1/v minus 1/u. This is the best way to remember. मिरर में I means बंदर का भाई, I is there in addition, तो 1/f is equal to 1/v plus 1/u. लेंस में E, नेगेटिव में E. concludes. There's nothing more. So now it is the time. Okay, what I say. Now I'll just stop the recording here.